Hi and welcome to this video. This video will deal with missing values in your data, in your Python Jupyter Notebook data set. So if you want to know where we were in the previous videos, you can have a look at the other videos up top here. You'll see that with the previous videos, we got onto the stage of a year, and now we're going to be dealing with missing values. So firstly, we're going to be looking at your standard missing values. I've got this code over here. I just want to run this code so we can see exactly what I've got here. If there is a hashtag, then whatever the code is or whatever the writing is after the hashtag, Python doesn't pick that up and it sees it as invisible. So it doesn't run these first 3 lines of code over here. It runs this 5th line. What I'm asking it here is to indicate the columns called value and missing. And in the value column, it's going to look at the missing values is null of the balls. And in the missing column, it's going to indicate if there is a missing value in the balls column, then it will indicate a false. And if you look over here, you can see that there are 125 rows. And for example, row 0 is false, false, row 1, row 2, false, and all of these are false. But keep in mind that ellipsis over there indicates that not all the rows are indicated. NaN, not a number, indicates that it's a missing value. So the next line of code, I'm going to identify the Na as well as the NaN values. And if you want to know what the Na and NaN values are, I gave a brief description in the previous video. So let's run this code. Remember, if it's highlighted blue and I press Shift Enter, it runs the code. So Python has now generated all of the columns and all of the rows. You can get a better sense then for whether or not they're missing values. So it's very difficult now because it hasn't highlighted every single row over here. So you don't get a sense of all the rows. But you do notice that especially towards the bottom end of, in particular, in this case now, row 124, which remember is cricketer number 125, there are a couple of trues, which means there are missing values in there. And you can recall from earlier in the previous video, if you go up here, you can see that Zubair Hamza has missing values over there. Right, so what we're trying to do now is we're trying to identify whether or not there is missing values. And then we're going to decide what we're going to do with the missing values. So now I've run line number 50, this code over here. So what I'm doing is I'm filtering the rows that have missing values in. I call it NA rows, looks from the data file, is NA, in other words, missing value, and then I print all of them. So this output generates all the cricketers who have missing values in the rows. So you can see Andrew Hudson right down from number 5, more recently Heinrich Klaassen, Carl Verreynne, more of our recent cricketers, 2003, 2004, Quinton de Kock, Tony de Zorzi, Tristan Stubbs, Zubair Hamza. So these cricketers do have missing values in the data. We will have to decide what we are going to do with that. Why do the BBI wickets and the BBI runs have missing values? That's because some of those cricketers have never bowled in Test cricket. So in other words, again, as I mentioned in the previous videos, the domain knowledge is crucial. We know that not all the cricketers bowl, and we also know that not all the cricketers are not wicket keepers. So if they are not wicket keepers and they don't bowl, they probably aren't good enough to play as a bowler, or at least to bowl as a bowler. So hence there are missing values, even in those columns that we generated in the previous videos, where we split the string or the object column BBI into 2 numeric columns, BBI wickets and BBI runs. So because the players have not bowled, what I'm going to do now is I'm going to look at the missing values per column. So you can see here, again, as I've done in the previous output in previous videos, if you look at the batsman, most of the missing values are not in the batting side of the data. But clearly they are on the bowling side of the data, which means that we would expect that most, if not all, of the cricketers have batted at least 1 innings. Hence, no missing data. We would, however, also expect that many of the cricketers would not bowl, hence the missing values in the bowling side of the data. So again, that is expected. Let's look at the specific rows where there is missing data again, just to highlight. Just another way of identifying it as in comparison to the code generated up here in line 50 or input number 50. So it's always good to have various ways to use code because sometimes certain code is not going to be working for certain types of data. Let us look at the number of missing values per row. So again, you can get an indication of, especially the last number of rows here, Zubair Hamza, I know, because we've referred to him quite a bit at the bottom here. There are quite a bit of missing values for Zubair Hamza, but not necessarily for all of these other rows. Remember, what we're doing now is we're trying to get a sense of how many missing values are. So in this line of code, I say identify the missing values in every particular row, so you can get a sense now that for cricketer number 1, which is Andre Nel, there are no missing values. Cricketer number 5, if we go up, let's see, cricketer number 5 is Andrew Hudson. Andrew Hudson has 17 missing values. Now, I know my domain knowledge tells me that Andrew Hudson was not a bowler at all. Therefore, I expect the missing values to be around the bowling data. And as I go down, you can see that 16 to 17 seems to be more or less the average, which again you would expect because the batsmen that are not bowlers would have no bowling data. Hence, the values would be around about the same for all the missing values in the data, particularly in the data pertaining to the bowling. You can see 15, 16, 17 is around the norm on the high end. There are a few 4s that are quite common. That might pertain to a certain type of, maybe they've bowled, but they haven't taken wickets, or they haven't got best bowling in an innings or best bowling in a match. Nothing out of the ordinary. The next line of code highlights first 25 rows. We've got Andre Nel, Anrich Nortje, Alan Donald, AB de Villiers. Those are the first 5. Andrew Dawson. And then right at the bottom is number 24. Remember, it's 25 rows. We start at 0. Remember that. Charles Willoughby is quite an interesting one. There are no values at all for any of the batting figures. But I know that Charles Willoughby is a bowler, so you would expect him to have bowling data, which he does have. Now we need to decide what are we going to do with these cells that have missing values. The one thing is we can drop a particular row, but if we drop a row, then we are losing information. And if we lose information, it means that we are losing data that can be meaningful for our interpretation of the data. It's not always ideal to drop rows, definitely not to drop columns, unless, of course, the majority of the cells do not have data in columns. Rows are probably a bit more discretionary because that means maybe dropping a particular cricketer, in this case now. So dropping 1 or 2 might not be such an issue, but dropping an entire column, that takes a lot of information away. If we look at this data again, what I've highlighted, as I mentioned earlier, is that cricketer number 19, which is the 20th entry, Charles Willoughby, has no data when it comes to the batting. Now the question becomes, should we drop Charles Willoughby from the data? Is Charles Willoughby such a cricketer that it justifies us to drop him from the data? He's only played 2 test matches, as you can see over here. He hasn't batted once in those 2 test matches. He has, however, bowled. His best bowling figures are 1 for 47. He's a medium-fast bowler, left-handed, not particularly stand out at all. Only 2 test matches. When I think of him as a cricketer, he didn't play at all long. He only played for that 1 season in 2003. On the back of that, dropping him will not be such a major impact on the data. So in that view, I would drop him. So I'm going to drop him, especially because none of his batting figures are listed. So there's no batting because he hasn't batted. And we won't lose too much information because he has not played many tests. His figures don't stand out too much. So let's drop him. We run the next line of code where we remove a specific line. You can see row index to remove, row 19. Remember, he's actually number 20 because we start at 0. So now we're going to go, line 3 says data drop. We're going to drop the row index to remove, which is row 19. Shift enter. You can see there's no output, but the number has shown 56 and there's no error. That means Python has run the code successfully. So let's now look at the top 25 rows again. And what you'll notice is Charles Willoughby's gone. He was number 19. Now there's only an 18 and 20. So number 19 is gone. So what Python does is it removes entry row, in this case 19, and it doesn't cause row 20 to become row 19 anymore. The row number allocation stays the same for every single row. That means if Dane Patterson was row 24 before the deletion of Charles Willoughby, he stays row 24 after the deletion of Charles Willoughby. So keep that in mind. That's a very useful thing, especially if you've got a view or you're familiar with the data before any deletions. So let's print now the rows with missing values again, just to get a sense. And you will see that row 19 is gone. Now, what about non-standard missing values? These are values that might have specific numbers. Now, often, you know, especially corporate data, let's say at banks, when they don't have data about you, maybe your cell phone number, whatever, instead of putting nothing in the cell, they have to put a number, which is the way of the system to force you as a banker to get the information from your customers. But if they don't have the information to allow the system to take your particular entry, what they often do is they put, say, 10 nines or 10 zeros. I recall looking at the data earlier and seeing certain funny numbers. So let's have a look at that. So let me run this line of code over here just to get a sense again. Remember, we said now missing values, especially in the final row, they are true. Let's now create a data frame. So let's run the next line of code. Shift Enter. If you look at the code that I've assigned here, you're looking at the new data frame. I've created a new data frame where I'm looking at the value specifically for hand bowl. In other words, whether or not they are left or right-handed bowlers. And again, if it is a missing value, or in this case now nan, not a number, then what it will do is it will indicate a true if there is a missing value or a false if there's not a missing value. So all of these entries over here, these rows, and I know number 5 is Andrew Hudson. They are missing values for Andrew Hudson. Remember, what we're doing now is we're trying to find these missing values. It's a very good exercise to repeat a lot of the code as you make changes to get a better sense of whether or not you've addressed certain missing values or not. Again, just to reiterate what I've said, if you look at the specific missing values in the columns, I use this code over here. What is the missing values for a column? For all the columns, number of missing values. So in player, there's no missing values. For span, there's no missing values. All of these over here. Again, you can notice another trend that there are missing values only, it seems, on the bowling side of the data. If you want to know if there are any missing values whatsoever, you can use this code and it tells you true. When you're looking for the missing values, the first thing you could do is run this line over here to find out if there are missing values. Python will tell you if there are missing values. Then you can go and look at specific columns with this line of code. Then you can go and look at specific rows with this line of code. Although I've done it in a certain order, by no means does that restrict you from doing it in a particular order. So keep that in mind. There's no silver bullet with code and the usage of the code. So if I want to know how many cells of missing values there are, I use this one, data is null.sum. And there are 482 cells with missing values. Now that's a lot. If you keep in mind that there are 25 columns and 124 rows, 480 cells is quite a large number. Now we're going to replace them. We're going to decide now, what are we going to do with these missing values? The first thing is we can replace them. If you run this line of code, what I've done over here is I have given you some code that you can use if you want. Now I haven't inputted this code because there's certain things I want to do. This line of code over here allows you to replace all the missing values with a mean. This line over here replaces all the missing values with a median. So you can decide based on your domain knowledge, based on what you think is most appropriate to analyze the data. I don't think inputting the mean or the median is relevant for the data on South African cricket test cricketers. Not at all. And the reason for that is there's no logical reason why a batsman like Andrew Hudson and a bowler like Dale Steyn could be assigned an average when they are clearly on different levels with regards to their batting prowess. So it doesn't make sense giving Dale Steyn the average for all batters, and it also doesn't make sense giving Andrew Hudson or AB de Villiers or Graham Smith or Jacques Kallis the average or the mean for all cricketers. It just doesn't make sense because they are much better batters than what Dale Steyn is. So it doesn't make sense giving them the mean. What we need to do then is think of a different way to input the missing values. If we look at the rows, if you want to calculate the mean or error, notice that if I calculate the mean or median for each row, which I want to input, say if I wanted to input it, it gives an error. Now, why do you think there's an error? The reason there's an error is because there are string values in the data. You can only calculate a mean if it's numerical data, if it's integers or floats. You cannot calculate a mean if there is a string. If there is an asterisk or an @ sign or a / or a $sign, you cannot calculate a mean. So that means the data is dirty. The fact that you can't calculate the average or the mean is a problem. So we need to clean that data so that we are able to calculate, for example, the mean for future analysis. Now, one thing we can do is, as I mentioned earlier, if you recall when we looked at the data in the previous video, there was a funny number. There was a number with several nines. What I'm going to do now is I'm going to ask Python to identify that cell where that number was. So Shift Enter, and there you can notice Alan Donald under the balls has this number. It's unfortunate that we don't have the number of balls bowled by Alan Donald because he's one of our best bowlers of all time. So we would have liked to see how many balls he's bowled, but from all accounts now, there is no data on that. We can't let that value. That is a major outlier. It's obviously not correct. So we need to change that cell. I run the code and I put a instruction for Python that it must assign that value of 999 a space. And if you see over here, Alan Donald, it's an open space, which is a missing value essentially. So we have replaced that odd number of all these nines. If you want to identify a line of code that can identify specific funny numbers or values that you are aware of, you can use this .lock function. The missing values can also be addressed based on the problem that you're trying to solve. Once again, let's just look at the missing values and get an idea. If you want to replace the missing values with zeros, then what you can do is you can run this line of code. Now, the error that you see here suggests that there are categorical values, because if you look at the error, it says, cannot set item on a categorical or a new category, 0. It doesn't make sense. We know that there are categorical columns, such as hand batsman, hand bowler, left, right. We need to look at this differently. Let's look at the different categorical variables that we have over here. I'm going to run this code, and in this code, what I've done is I've defined the categorical variables, and I'm now going to see whether there are missing values in the categorical variables. And yes, they are. So let's just look at this code. What Python does is it iterates over each column in the data frame, then it checks whether or not it is categorical, and if it is numerical, it will replace it with a 0. If it is not numerical, then what it will do is it will pass over it. And then we must decide what we're going to do with these categorical variables. Line 70 then identifies, after all this code has been run, if there are missing values. And yes, they are. So now we're going to see how many there are. Remember, I've now reduced the number of missing values from, if you're going to look at the code up top, 482 open cells. And the latest line of code, which I asked Python to put zeros in, over here, it reduced it to 440 odd cells that it put a 0 in. Right, so there are 43 missing values. Let's see where they are. And we can look at this column, number of missing values. You can see the majority, if you recall the earlier outputs, the values in the bowling side of the data, there were many missing values. But now, the only missing values are in the type, in other words, the type of bowler, or wicketkeeper, remember, and the whether or not the bowler is left or right-handed. Let's think about that now. Clearly, in the type of bowler, there will be missing values because not all batsmen have bowled. So those missing values are probably batsmen that have never bowled. In terms of the hand bowl, the missing values are probably because those batsmen haven't bowled. There's been no data put in the cells with regards to them bowling. What must we do with the hand bowl in the first place? What we could do is we could assign the same arm hand that they bat with and assign it to the bowling hand. That might not be 100% accurate because not every single batsman, if they bat right-handed, necessarily bowl right-handed. Some might bat right-handed and bowl left-handed or vice versa, but it is probably very close to accurate. There might be one or two that are not necessarily the case, but in general, that's probably a fair allocation in terms of handling the missing values for batsmen who don't bowl. The assumption that they use the same hand to bowl that they do to bat. Of course, ideally what you should do is you should identify those 26 cricketers and go find out. 26 is not that many. You should go find out exactly whether or not they bowl right-handed or left-handed. But the problem is, wherever you're going to find that out, there won't be data on it. Because if they've never bowled in test cricket, then even the data analysts that inputted the data don't know if they bowl left or right. So in reality, the only way that we will know whether or not they bowl left or right-handed is based on what they bowl in the cricket nets at practice. There is a bit of subjectivity in the allocation of them. So how are we going to handle these last two columns? Let's look at the hand bowl now. And as I mentioned earlier, the way that I decided to deal with this is I am going to assign the same arm that they bat for their bowling. So I've run this code now where I specify the columns in which I'm going to be looking for, the type and the hand bowl, and then I'm going to use a Boolean, and a Boolean indicates either yes or no, to select rows with missing values. Then I'm going to print them. You'll notice here, if I count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 handball. That makes total sense over there. So there you've got your 26 rows or cricketers that have missing values in terms of the handball. And if you look at the handball, if you go down, again, you can see over here. Now notice in the type that have missing values are all of those that are not assigned either a bowler as a bowler or as a wicketkeeper. So in other words, if we go back to this figure over here of 17, the value there is indicative of batsmen who have never bowled. Because it's a categorical variable, it might actually make sense to assign these missing values as batsmen who do not bowl. So that's exactly what I've done in this line of code. Replace the NaN values in the type column with DNB, did not bowl, DNB. So let's run that code. You'll notice then there's an error. Now the reason there's an error is because you cannot assign that new category unless you add that new category to the existing categories. So that's what the next line of code is. I'm going to add DNB to the existing number of categories. And then the next line of code, I'm going to say replace the missing values in the type column with the did not bowl category. In line 74, where the error is, there's an error because there is no category assigned. Then you assign the category to the missing values. And then this line of code over here replaces the missing values with the did not bowl. Right, so let's now look at whether or not there are missing values in the type column. And you can see 0. No missing values. Great. Now, let's just run an additional line of code to see if there are any unique values, or rather what the unique values are. So if you look at the type, remember type is the type of bowler, medium, fast, medium, fast, express, pace, off break, whatever. And you can see at the end here, it's added, did not bowl. So that's great. Now, what about the hand bowl? There are 26 missing values. And the way that I've decided to approach this is, like I mentioned earlier, I'm going to replace the hand bowl column with the same values that each respective what their value is in the hand bat. So I'm assuming that the missing values for the batsman with regards to how they bowl is the same as the arm that they use when they bat, which is not 100% accurate, but let's work with it. So let's check if it's done it correctly. So this line of code then indicates whether or not there are null values, in other words, missing values in the hand bowl. If it is 0, in other words, if there are no missing values, then it will print that there are no missing values and will say the missing values in hand bowl column were replaced successfully. If there are missing values, in other words, this is not a 0, then it will say there are still missing values. So I'm giving you all these different lines of code that you can use in interesting ways. Because there are no more missing values, Python prints this. If there were missing values, that's what the else function is. So if this is true, then this will be printed. If it is not true, else, this is printed. So it is therefore true because there were no missing values, hence this output. If you look at the last line of code over there, we look at all the code, every single column, great, there are no missing values. So based on our pre-processing of the data, we have eliminated all the missing values in the data frame. Now, we do know that we weren't 100% accurate, especially with regards to the assignment of the same arm, the same hand for bowlers who have never bowled in Test cricket, because we don't know. What it means is when we start doing the visualizations and we start analyzing, especially the hands used, or whether or not they're left or right-handed, we must be very careful to interpret that, especially with regards to certain cricketers. That is why it's important to know your data. In the next video, we will then deal specifically with duplicates in the data and make a call as to how we would address them.